This is Dan Abbott. This video will cover weldments in SolidWorks with an overview of the process of creating weldments and some suggestions for avoiding problems or potential problems down the road. The weldment process requires that you take a profile and sweep it along a path like a swept solid. The profiles that come shipped with SolidWorks are quite limited. There aren't that many of them, and so you're probably going to want to either download more or make your own. Now, you can find profiles online. Companies often provide weldment profiles of tubing that they and other kinds of shapes that they manufacture. But if you go to the library file on the right hand side of the SolidWorks window, and under SolidWorks content you open up weldments, you have several different standard size profiles that you can download, which will give you thousands of additional profiles. I'm going to hold the control key down, left click, and just drop these in the templates folder. Now, this is not where SolidWorks is going to be looking for these weldment profiles when you make a weldment, at least not by default. So I'm going to unzip this, but I'm going to unzip that file into the location where SolidWorks will be looking, which is on the C drive, Program Files, SolidWorks Corp. SolidWorks, Lang stands for Language, English, Weldments, and that's where we want to put them. So I'm going to select that folder, go ahead and do the extract. Let's do this for all current items. Continue. I'm giving administrator permission. I'm going to start the process, and now what I'm going to do is, as it's going through, I'm going to pause the video and then come back just to save some. And I'm back. Now we have a folder in the Weldments profile location called ANSI Inch that has been populated with a large number of categories or types that didn't exist when you first installed SolidWorks. The location, for instance, for rectangular tubing. This is all you get when you download SolidWorks and install it for the first time. You just get 3 sizes of rectangular tubing. If you look at what I just downloaded, if I get down to tube rectangular, I now have hundreds or at least dozens of different sizes for rectangular tubing. Now I'm going to show you how to use a weldment profile to create a weldment, and I'll show you how to make your own weldment profile, which is quite simple to do in the event that you don't have what you need from the downloaded files. So we're going to start a part file. Weldment profiles are created as sketches in a part. So I'll go to the part file, I'll go over to sketch on the front plane, which is what you want to do. Well, it's what you want to do depending on the orientation of your weldment. I'm going to draw a center line down through the origin and make a symmetrical weldment, just a simple part that's angled, comes up and across, stop at the center line, and I'll mirror those entities around that center line. Now I'll add some dimensions. We'll make this 120 inches wide. I'll make it 26 inches tall, and we'll make the angle between that leg and this one 120 degrees. So now I have a fully defined sketch. I'd advise you to always fully define your sketches for both profiles and for paths. Once you have a fully defined sketch, you can exit the sketch, and now you're ready to create a weldment. Now, to create a weldment, you need to actually go to the Weldment ribbon. That tab will not be showing if you've installed SolidWorks with the default settings. It'll look like this. It might look a little different, but if you go to the tabs, right click, you can pick weldments off the list. Now I go to the weldments tab, I'm going to create a structural member. So I'm going to create 3 structural members. Now I'll go down and pick my standard. The standard I want is ANSI Inch. Custom, by the way, shows up because I've identified a custom location to look in as well, and I'll show you how to do that in a minute. The type we want, again, if we've gone to those that were shipped by default with SolidWorks, we go to rectangular tube, and now we only have a choice of 3 sizes. If we go over to tube rectangular, the folder that I just downloaded and unzipped, now we have dozens of sizes. So if I pick one of them, we'll just pick 3.5, I'll pick 4 by 2. That's the profile. It's a 4 inch by 2 inch square tube with a wall thickness of 3/16. So that's the shape I'm going to get. I'll go down and highlight the groups window, and we're going to make a new group. Now we can do a three-dimensional sketch to do a weldment, in which case you'd want separate groups. And I'm also going to add some cross members to this, and I'm going to add those with a smaller profile, so I'll use that as a separate group as well. But I'm going to pick this leg, and this leg. By default, the corner treatment end miter is selected. That's what I want. I'm going to go and look and see how it came in. You'll see it came in oriented with the short dimension in the front view and the long dimension going in the Z direction, and it came in at a pierce point on the profile, which was right in the center of the rectangular tubing. I'm going to change both of those things. Suppose I want to change the angle, which is what you should do first. I can rotate that 90 degrees, so now I have that tubing oriented in a different location, a different way. And then if I select the Locate Profile button, I can say I want that overall path to dimension this weldment on the outside of the weldment, not down the center. Now what I've just created is a multi-body part. I've got three bodies, one here, and one here. They are not merged. And I don't want them to be merged because I'd like to create a set of welding drawings that allow me to see these edges. I'd like to treat each one of these as a separate structural piece so I can create a cut list. Now I can edit this collection of bodies the same way you edit any other SolidWorks part. If we look at it from the front, you'll notice that I have a square end, which is what the default is. What I want to do is to cut that square end off so that it's horizontal. So what I'm going to do is to go and just sketch on the front plane, and I'll sketch a rectangle using the corner to corner option. And I'm going to put a rectangle that goes from that corner, make sure it's on the outside, over to this corner. Yeah, I'm going to make sure I can see that looking straight at it. I'm going to take that corner and match it to that point right there. So we'll put a coincident relationship between those two. I just paused the video and now I came back. The reason I was not able to add that coincident relationship is because I had checked off add dimensions when placing in the rectangle features. I'm going to have to get rid of that dimension. And I'm also going to get rid of this one because I'd like to move each of these points so that they correspond to the area that I want to trim. So I'm going to take that point and this point right here, make them coincident. Try that once again. Make those corners coincident. This corner I want to line up with that point. I want it to line up with this point. So I'll make a coincident relationship between this line, that point right there. Now I have a fully defined sketch, and what I'm going to do is use this as a way of cutting those legs off so that they're horizontal. So we'll go over to Features. We'll do an extruded cut the way you would any other SolidWorks part. I'm going to go in two different directions with this. So my first direction is going to be up to surface, and I pick that front surface right there. My second direction is also going to be up to surface. Pick that surface right there. Click OK. Take a look at this isometrically, so you see I've now edited this so it sits flat. Now I'm going to make my own Weldment profile to show you what to do in the event that you have a specific size that is not included in the downloaded versions. I'll just throw this away. I'm going to start a new drawing. I'm sorry, a new part file. Part file, I'm going to go to Sketch. Sketching the profile I'm going to do on the front plane. I'm going to use the center rectangle option to make the square tubing. I'll make it, let's make it 5 by 3. So I've drawn this, I've dimensioned it. What we want is rounded corners, so I'll go ahead and add fillets to those corners. We'll add fillet that is 1/4 inch. at each of the corners. Now I'm going to offset this outside. By the way, I'm leaving those corner to corner construction lines in there because they give me these points that I can use to snap to the corners when I bring it in if I want. So now I'm going to do an offset. We'll make the wall thickness of this, say it's 2/10 of an inch. That's why we have to make our own. Reverse the direction, have it go inside. So we have our tubing profile all made, and then just one last thing I need to do before I save this is I need to add a point at any location that I might ever want to use as a pierce point on the welding profile path. So I'm going to go to the point tool under sketch, and I'm going to place a point at the midpoint of each side so that if I want to, I can use that midpoint as a location on the path for this profile. That looks good. Come out of the sketch, and this next step is critical. You'll get an empty profile if you don't do this. Make sure that the sketch you just created is the only thing in the drawing, that the only thing in the sketch is what you want included, either as locations for pierce points with a point, or construction lines, or regular lines. But also make sure that the sketch is highlighted. And if it's not highlighted and you just save this as a part file, it won't work. So I've highlighted sketch 1. Now I go to the file pull down and do a save as. But again, make sure you've highlighted the sketch before you do the save as. When I do the save as, I'm going to change from a part file to a library feature part, and I'm going to go to a location that I've created that is separate from the SOLIDWORKS location. I could go and put it in the SOLIDWORKS location as well, but if this is a custom profile, I'm going to put all my custom profiles in one location so that I can go there and it's a little easier to make the selection. So on the C drive, under the folder called Dan, under a folder called SolidWorks, I have a Weldments folder, I have a Weldments profile folder, and under that Weldments profile folder is a folder called Custom. What I'm going to pick is Profile folder. And I have a folder I've created called Rectangular Tubing. I'm going to give this a size. I made my rectangular tubing 5 by 3 by 0.2. I'm going to put 0.2. Now I've got the name of the profile is the size of the profile itself, the size of the tube. Decide on a standard naming convention and then just keep using it and make sure you're consistent. You might want to put rectangular tube in this file name. You might want to put RT. I'm going to add a description because the description can be placed automatically in a cut list. So in my description, I'll do rectangular tube. And I'm going to highlight the size, and I'm going to make sure that the title of the file, or the name of the file, matches my description. So rectangular tube 5 by 3 by 0.2 will end up being a description property that I can then put into a cut list automatically. So this would save a tremendous amount of time down the road. I'll save this. Now I'll start a new drawing. The new drawing is going to have a profile in it. It's also a part drawing. So I'll go ahead and do a sketch. Again, I'm making this on the front plane. I'll make the same kind of simple shape we made before, and then we'll add a few more weldments and structural members to it. So I'll draw a line that comes up here, comes over here. We'll mirror it. But before I mirror it, I need to have a center line. Center line's fully defined except for the ends, but it's fully defined enough for us. So now we'll go ahead and mirror those two lines around the center line. Put some dimensions on. We'll make this 120 inches long. Make the height of this 40 inches. Now you might think it would be helpful to put the length dimension along here, but the fact is you're probably designing to certain overall widths and heights, you'll be able to pull a dimension of the length of that off directly. In fact, SolidWorks will do it for you and place that as a category in the cut list. So there's no need for you to dimension in an aligned fashion here. You can just dimension the overall height. Now we'll put an angle in between. I'll make this 120 degrees again. So there's my profile. It's fully defined. Not my profile, there's my path, and it's fully defined. Now we come out and we'll go back to the Weldments tab. Under the Weldments tab, we'll pick Structural Member again. But instead of ANSI inch, I'm going to go to Custom. Under Custom, I have rectangular tubing and square tubing. So under rectangular tubing, the tubing profile that I just made, I called 5 by 4 by 0.2 by 0.2, not by 0.25. It was 5 by 3 by 0.2. So that's the one that I want to bring in. I've identified the profile, highlight groups, make a new group. These can all be part of the same group because they lie in the same plane and they're continuous, or either one of those things has to be true. One of those has to be true. Either they have to lie in the same plane or they have to be continuous. I'm going to take a look and see how it brought it in. And see the way that it brought it in here is oriented so that the long dimension is on the z-axis and the shorter dimension is in the front view. Along the x-axis, sorry about that phone ringing. I'll try to edit that out later. So I want to do two things. I want to rotate this 90 degrees so that it's oriented differently. And I also want to change the pierce point so that instead of being right down the center, right down the center of the profile, I'd like it over on the outside so that the dimensions I place will become the outside dimensions of that structure. So over on the left under the Feature Manager, I drag the little slider down. I'm going to type in 90 for 90 degrees, and you notice it rotates that whole profile 90 degrees. Then I'm going to go to the Locate Profile button just beneath it, and then pick that point that I placed at the midpoint of that side and say put that as my pierce point. It comes inside now. Now if I take a look at this isometrically, you can see that it created three different bodies. So this is a multi-body part. That means that they weren't merged and you don't want them merged. You want them separated just the way they are. Now once you've got this, you can edit it the same way you would edit any other part in SolidWorks. Put holes in it, you can cut pieces away. What I want to do right now is to cut that piece out of the bottom as I showed earlier in the video. I'm going to pause the video and do that. Then I'm going to come back and add some cross pieces that come across here and give you a little bit of advice about how to make that work as well as possible. Okay, so I have that basic shape. Now let's say I want to put some structural pieces that go across, and I want to make those a different size than the structural piece that I just created. What I can do is sketch again on the front plane, and if you set your drawings up correctly or your parts up correctly, sketching everything on one plane, which is down the center of your structural weldment, can make life a lot easier. Now I'm going to draw some lines, and I'm just going to draw them so that they start on the edge of one part, go straight across in a horizontal, stop on the other part, hit the escape key, go back in the line command, yeah, one of the things that's happening is I've got to be careful not to snap to the tangent line. One thing that might make that a little easier to do is if I come up to the display and change from shaded with edges just to shaded. Now I'll draw my last line. I would just go from, well, you know, that's still going to go to the tangent line, so that didn't really help me. So just be careful you go to the right location. Those tangent edges lines can really be a problem. Okay, so I've got three lines now. Then none of them are fully defined because the overall length of them isn't nailed down. We can move them up and down. So let's just say we want this line to be a certain distance from the bottom, we want this line to be a certain distance from the top, and we want this to be halfway in between them when we put those cross pieces. And let's just say that the percentage, we'll do a ratio here. We want this one a little closer. So let's just say we want this one about that distance away, and then we'll have this one say right about there and this one here. Now what I'm going to do is set this up in such a way that if I change the overall width or change the overall height, these will automatically update so that I don't have to worry about going back and redrawing them. So in order to do that, I'm going to put a little construction geometry in. The construction geometry is going to consist of construction lines that I can dimension to, and then I can use those construction lines with the dimension I place on it as a way of defining another dimension, which is the distance between each one of these lines. I'll start by putting a dimension that's aligned on this outside edge. Now this is going to show up with a message asking me it's not going to ask me anything because I'm trying to dimension a line in a different sketch. I need to start with the construction line, as I said, and I'm going to draw a center line that just sits right on top of this line and goes from here to here. In fact, just so it's not obscured by the other sketch line, I'm going to actually go down to the inside and do that instead. And just make sure I got to the right location, which I didn't. I got to that tangent edge. I'll delete that. Make a coincident relationship between that point. This one, we have a black line, so now that's all set. So now what I'm going to do is to put a smart dimension on that at an angle, and it will give me a message now. Yeah, the message is, do I want that to be a driven dimension? Because I've identified the endpoints of this line as being coincident with those corners, the overall line was already fully defined, so I can't put a dimension on there unless I want to override it or make it driven. I want it to be driven. I want to use it, but I don't want it to drive anything. So now I've got the overall length of that line, and what I can do is say I want this part right here to be up with that distance right there to be, let's say, 10%. Let's say 5% of the overall length. So I go to place it, and instead of typing in a value, I'm going to type the equal sign. I'm going to pick that driven dimension. It shows up in here with its name, which is D1 at sketch 13 in this case. And I'm going to multiply that length by 0.05. Now I have an equation-driven dimension that's going to keep that distance right there proportional to the overall length of the inside, so that it's always 5% of that distance. I'll do the same thing up here. I'm going to make this one 10%. So we'll say equals times 0.1. So that top line is fully defined, and the way it's set up right now, it's always going to be 10% of the overall length of the inside of this down from the top. So it's just to make it proportional. Now what I want to do is to make the dimension between here and here, and the dimension between here and here equal. So I'll make a dimension that goes from that point to this point. And in the process of doing that, I discover I have an error in here, and I'm going to go find that error, and I'm almost going to guess that it's the tangent edge rearing its ugly head again. And it is. So I need to get rid of that coincident relationship by highlighting it and pressing delete. And then I need to make a relationship between this and this edge that is coincident. Now it's on the inside. Now when I place my smart dimension from here to here, you notice how it now lines up with the original dimension. So now I'll place this, and what I want to do is make this a equal division, equal distance between these two right here. Since I've already made the overall length from here to here 10% of the distance of the overall, and I made the one down here 5%, that means 15%. I have 85% left, so if I make this dimension half of 85 times the overall length, so I have the overall length in there by typing the equal sign. I'll pick that dimension. I'll now multiply it, and if I don't feel like doing the math in my head, I can type 0.85 divided by 2 in parentheses, so I have an equation. And now what I've got is a fully defined sketch. It tells me that right here, because if that's half of 85%, this must be half of 85% as well. This may seem like a lot of trouble to go to, but if you're doing a lot of these things and you've got various heights and widths of this particular structure that you want to manufacture, this allows you to make those changes to the height and width without having to go in and worry about making a change here, as long as what you want is for the spacing to still be proportional. Now I'll come back out. We're going to go ahead and make another weldment. This time I'll go to the weldment section, structural member. I'll go to ANSI inch and pick one of the existing ones. We'll go to tube square. Now we've got all kinds of sizes here. I'll find 2 by 2. Let's say we want 2 by 2 by 3/16 of an inch. So I'll pick that, make a new group. My new group is the distance from here to here to here. Pick OK. Now I've got a little problem. The problem is that part of this corner is embedded in the existing structural member, and there's also this gap here. There's a really nice little tool for handling both of those things at once, and that tool is called the Trim Extend tool under Weldment. If I pick the Trim Extend tool, it asks me to pick a body to be trimmed. Now what I want is to trim this body right here, but I also want to trim this body right here, and I want to trim this body right here. Now what I want to trim to? A face. So down here it says face or plane. So I select that window, I come in and I say what I want is for that to be terminated by this face right here. The minute I do that, it extends the bottom so it hits the face, and it trims the top so it hits the face. Pick OK like this, and now I have the angle that I want for that cross piece. I'm going to go back and put this on. Now the reason I like doing that is because I can go back to my original sketch right now. In the original sketch I can say, you know what, we want this to be 100 instead of 120. And we want this to be 35 instead of 40. Come back out. All those changes are made. It's updated, and if you see this cross pieces, they're still in the right location. Okay, I don't mind the fact that I've made all these mistakes, because you can see obviously things didn't work the way I wanted them to work right here. And the reason is because you probably note that I paused the video. The reason why it didn't appear to update is that I hadn't rebuilt the part. Once I rebuilt the part, now I still have that same spacing. We'll try that one more time. So if I go back into my original sketch and edit it, now I'll make this 160 overall length. I'll make this 45 in height. Come back out. Now it doesn't look like it's going to work right. When I press the rebuild button, now it rebuilds and everything looks good. If I look at it right from the front, I still have my 10%, 5%, and then the equal spacing in between. Now you notice I didn't do the other end when I did my trim and extend, so I'll do that one more time just to show you how it's done. Go back to trim and extend under weldments. I want that body, and that body extended. And I want all three of them extended too. That face right there. And it knows, I mean, if I wanted to keep the piece that's on the inside and discard the overall length, I could change this, but I don't want to. So I come back out, and now I've got the part going all the way across. That's nearly a 30-minute video, so I'm going to stop this one. I'll make another one on creating a weldment drawing from a weldment.